let's address all the concerns. Let's address all the misconceptions. Let's know how to calculate compound interest. Alright, so first thing that we would want to do is that we want to first identify or differentiate between simple interest and compound interest. So before we learn about compound interest, let's quickly compare it with simple interest. Now, simple interest, the interest is calculated only on the original amount of money. For example, if you invest $1,000 at 10% per year, for the first year the interest would be $100. Why? Because that would be 10% of $1,000. The next year the interest will also be just $100 because that is 10% of 1,000. The third year is going to be, the interest on that money would still be $100 because that is 10% of 1,000. Notice that the interest stays the same every year because it is always calculated on the original cost, or sorry, the original money, or the principal. So that's simple interest. All right. Now with compound interest, that's where things start to change, because with compound interest, the interest is calculated on the new amount each year. So for example, if you invest $1,000 at 10%, that same rate as the example before with simple interest. For compound interest, if you're investing the same $1,000 at 10% per year, so after 1 year the interest will still be $100 because 10% of 1,000 dollars will just be $100. So the new amount, or the total amount in that account for after 1 year with the interest being added, would be $1,000 plus the interest and that would be $1,100. Now after the second year, the interest now is not gonna be on the initial $1,000 that was invested before. It's gonna be on the new amount, which is $1,100. So it's gonna be, in order to get that interest, or to find that interest, or in order to know the amount that you receive for interest for the second year, it will be the amount of money in the account, so the total amount, which would be 1,100, and that would be 10% off the 1,100. So the new interest for the second year would be $110. So that means in your account by the end of the second year, your new amount would be 1,210. So what that means is that if you notice something very important, the second year the interest is bigger than the first year's interest. Why? Because you are now earning interest on both your original money, that's the money that was invested, that's also known as the principal. So your original money, and also on the interest that was added already. So that is called interest on interest. So unlike simple interest, that every year passing, the money or what you invest grows by the same fixed interest year by year, the compound interest is not just 10% of the principal or the money that you invest alone year by year. With compound interest, your interest is gained with the money that you originally invested, plus the interest that you would have gained after that year. So that means that the interest grows year by year, and that's the whole that's what makes compound interest more fun, because it is called interest on interest. All right, so if the interest is compounded yearly, that means that every year the interest is compounded. Then this is going to be your formula, and this is a formula that some persons would have been exposed to, pretty popular. So that's P bracket, and P bracket means P multiplied by everything inside the bracket raised by. So that's gonna be P multiplied by, in bracket, 1 plus R over 100 raised to the power of T. Now some of you guys who are not exposed to the formula, you may wonder what is P, what's R, and what is T. And what I'll be doing is just to ensure that you understand everything completely. So many students make this mistake. The formula that you see before, it does not give the compound interest. So if I ask my students, how do you find compound interest? And even some adults, they say they'll give me this formula. But this formula is not what is used to find compound interest. We use the formula, yes, but that won't automatically give you the compound interest. What it gives is the total amount. So after the interest has been added, it will give you the total amount. So that formula that you see before is the formula for finding the total amount after adding both the money that you invested plus all the interest after a certain amount of years. So that's the formula for finding total amount. So the letter A stands for the total amount, and to find the compound interest only, so to find the compound interest, we must subtract the principal. So let's look at this formula right here. So the formula right here, this is the formula that we use to find A, and you know, whenever you see A means what? The total amount. So that's principal, the money that you invested, plus all the compound interest, or all the interest over a certain time period. P, so P means principal, and principal is just which represents the original amount or initial amount. So the starting amount of money that is either borrowed or invested, that's gonna be your principal. R is gonna be your rate, so yearly rate. So if it is charged at, you know, this rate yearly, T is gonna be the number of years. So whether the compound interest is for 5 years, 10 years, 2 years, 3 years. So T means time. T stands for time. R stands for rate. P stands for principal, and A stands for the total amount. Alright, so the compound interest right here, in order to understand this formula to find the total amount, you first need to see that these two formulas right here, they are the same formula. I'm just using these two formula, or this formula in particular, to show you why we have 1 plus R over 100. So this is what I am using to show you why we have 1 plus R over 100. So when you look at what it means that every year you keep 100% of your money plus your interest. So each year your money becomes 100% of your money plus whatever percentage percentage that of the money that is. So when written as a fraction, it would be 100 over 100 plus R over 100, right? So for persons wondering why we have 100 over 100, still remember, whenever we have a fraction, for example, if you have 100 over 100, it is the same thing as it being 1. So 100 over 100, once we have fractions where both the numerator and denominators are the same, it's gonna give you 1, because that's one complete whole. That means that that's the whole of the money, that's the entire money. So that's gonna be equal to 1. So that's how we end up having the 100 over 100 right here. If we simplified it, it would just be 1. And the reason why we say 100 over 100, because every year you keep 100% of your money, and that is being added to whatever rate is charged, and that rate right there represents your interest. So R over 100, if we say a percentage, the rate is normally given as a percentage. So percentage is over 100. So that's the reason why we have R over 100. So in the end, we have a formula right here for finding the total amount. So P bracket 1 plus R over 100 raised to the power of T. Alright, so let's move on from there. Now to find the actual compound interest. So we know that this formula right here, it is not the formula for finding the compound interest immediately, but it is used to find the total amount. Now this is the formula right here for finding compound interest, and that is A, which means the total amount, same thing for the formula right here, minus the principal, which is the original amount. So that's the money that you either invested or borrowed. That's the first money, the initial money, the original amount. So that's P, the principal. And when you subtract the principal from the total amount, we'll be able to find what our compound interest is equal to. So therefore, the formula for finding compound interest is going to be A minus P. And A being the total amount minus the principal, which is the original money or the initial money, either invested or borrowed. So remember this. Formula first gives you the total amount. So use the formula first to find the total amount. Then after, we subtract the principal to get the compound interest. So use the formula to find the total amount, A. So use the formula to find the compound, the total amount, which would be A, and afterwards you subtract the principal, and that will let you get your interest. So that's how you find the interest. All right, so with that, let's look at our first example. So example 1, calculate the compound interest on $4,000 on a $4,000 loan for 2 years at 6% per annum. So every year, that's the rate right there. So the first thing that I want to do is to say, okay, what is my P? What is my R? What is my T? So P, what's my P? What's my R? And what's my T? So principal is the original money that was the original money that's either invested or borrowed. In this case right here, $4,000 was borrowed. So $4,000 is your principal. The rate, what's the rate? The rate is gonna be 6%. Whenever you see the percentage sign or a percentage of something, you know that's gonna be the rate. So whenever you see the percentage sign, you know you're looking at the rate. So that's gonna be 6%. So the rate is 6%. And the percentage sign means over 100. So that's the reason why we have, you know, the 100 right there. And T stands for time. So our time is gonna be 2 years. So 2. Alright, now that we know what our P, our R, and our T is, we are going to plug it into the formula. So it's going to look just like this right here. So it's going to be P, which is P 4,000, so 4,000. Multiplied by everything in brackets. So we know that we're going to be 100% of our money. So that's going to be 1 because we have to have all our money being added to the interest. And the interest is just 6% of the entire money. So out of the 100% of the money, that would just be 6 out of 100. And for the time, that's 2 years. So we're going to find our total amount. So this is the formula to find our total amount, which is A. So A is going to be equal to 4,000 times A plus 6 over 100 raised to the power of 2. So what you're going to do first, because I know that some students struggle with what order of operation or what they should do first. So the first thing that we're going to do is work what is in the bracket. So work what is in the bracket first. So that's 1 plus 6 over 100. So that's going to be equal to, let's quickly just write everything below. So that's going to be, alright, so A, that's the total amount, is going to be equal to 4,000 open bracket. And let me do it step by step. So that's going to be 1 plus 0.06 0.06 raised to the power of 2. So what I did right there was just to find what is 6 out of 100. So 6 divided by 100 is going to be 0.06. For those who don't know how to divide 6 by 100 without a calculator, all you have to do is move the decimal point at the end based on the number of zeros. So you move the decimal point 2 times to your left. So that would be 1, 2. So you'd have decimal point coming right here. Space would be here. So that would be 0.06. Alright, so now that we have that, we can easily add everything inside our bracket. And remember, we are working what is in our bracket first. So we want to work what is in our bracket first before we do anything else. Alright, and I'm trying to do it step by step so that, you know, students can easily know how to work or use the formula. So A now is going to be equal to, and remember, A stands for total amount, not compound interest. So that's going to be 4,000. So 4,000. And 1 plus 0.06, that's going to be equal to bracket 1.06 squared. So I just added these two. 1 plus 0.06, that's equal to 1.06, and then we're going to square it. So next thing that we're going to do is to square it. And square means that you multiply it by the same amount. So that's going to be 1.06 times 1.06. So we're going to work this amount right here first. and I am definitely going to highlight it because I know that persons, I am not gonna assume that persons know how to work or know what squared is. So I am working this entire piece right here, and I'm gonna show you what that means. Alright, so let's first divide our page into two parts so I can continue working over this side right here. So this is gonna be my continuation part. So I'm gonna continue working right there. Alright, so let me continue. So I'm gonna continue working right here. Alright, so I'm continuing right here. So this right here, 1.06 squared, it means, so I'm gonna rewrite it now. So it's gonna be A equal to, so A is equal to 4,000 so 4,000, and we're gonna write what this means. So 1.06 squared is just 1.06 times 1.06. So I'm actually writing it out so students know what it means, because I want to ensure that, you know, everyone, no matter what stage they're on, they know how to work that formula. So why do I have 1.06 times 1.06? I have it 2 times because this number right here is being squared. That means that it is raised to the power of 2. So this 2 right here, which would be the time for 2 years, means that it is squared. So squared, anything squared means that the number will multiply by itself 2 times. So now that I have that right there, and I know that everyone knows what that means, now I'm gonna actually do the multiplication on it. So I'm gonna have it below, work it below right there. So that's gonna be A is equal to, so that's gonna be 4,000 times 4,000 times, and we put our 1.06 times our 1.06. So that's gonna be equal to so that's gonna be equal to 1.123 and 6. So it's gonna be equal to 1.1236. So after we have that right there, we know that that's equal to that. We just multiply that by 4,000 to finish it off. So multiply by 4,000, and after multiplying by 4,000, we're gonna have the total amount be equal to 4,900, 494.4, right? So this entire piece right here is my total amount. So that's what I found right there. So the formula, as we have finished using the formula to get our total amount, and our total amount A is gonna be equal to 4,494.4. So the next thing that we're gonna do, now that we know what our total amount is, so this is my total amount. Now that I know what my total amount is, I'm just gonna find my my compound interest. And we know that to find my compound interest, I will have to subtract the total amount. We're gonna have to subtract the principal from the total amount. So the initial money that we have, we're gonna just subtract it from the total amount in order to find our compound interest. So let's write it right there. So CI stands for compound interest. So CI stands for compound interest, and that's gonna be equal to A, and remember A stands for total amount, minus P, and P is the principal. P is the principal, that's the amount that was either borrowed or invested. That's the initial amount. So the P is 4,000, so we're gonna subtract right here. So the compound interest now, is gonna be equal to 4,000 So sorry, so that's gonna be A. So A is the total amount. Yeah, so A is the total amount, so that's gonna be 4,494.4 minus P is the principal, so minus 4,000. So after subtracting, we should get our interest to be equal to, say our compound interest for 2 years is going to be 494.4 dollars. So this right here is going to be our compound interest alone. So that's how we find what is our compound interest is. So after 2 years, the total amount after 2 years is going to be 4,494.4, and the interest is going to be 494.4 after subtracting the amount that we would have actually invested on our own. So that's how you find your compound interest. All right. So let's quickly go through question 2. So example 2. Calculate the compound interest on 5,000 for 3 years at 8% per annum. That means that every year it's gonna be compounded. All right, and we want to find what is gonna be our compound interest after 3 years. So let's quickly do this right here, where we are going to write what our P is. So our P is going to be equal to, so our principal is 5,000. Our rate is going to be equal to 8%. So that's 8. And 8% is 8 over 100. And our time is going to be equal to, we want to find the interest after 3 years. So 3 years. Alright, so time, principal, rate. So principal, time, rate. Alright, so let's do the calculation now quickly. So that's gonna be 5,000 open bracket 1, and remember that 1 represents all your money, that's 100% of your money, plus the rate, which is a 6% out of the 100% of your money. So that's gonna be, sorry, 8% of 8%, which is just 8 out of 100% of your money. So 8 over 100 raised to the power time. Time is 3 years right there. So what's that gonna equal to? That's gonna be 5,000 open bracket. So that's gonna be 1 plus 8 over 100. So we know that that's gonna be 1 plus 0.08 raised to the power of 3. So that's gonna be 5,000 times 1.08 raised to the power of 3, and raised to the power of 3 means that you multiply 0.108 by itself 3 times, right? So if we do that 3 times, that's gonna be, so that's 1.08 cube, that's gonna be equal to, so all of this is gonna be equal to, so that's gonna be 1.2 5 9 7 1 2 multiplied by, so multiplied by so it's gonna multiply that by the 5,000 now. So that's gonna be 5,000 times and 1.08 cube means that we're multiplying 1.08 times 1.08 times 1.08. I will get this for your answer. Let me highlight it. So after finding 1.08 cube, you'll get that for your answer. And to find what is going to be our total amount, I'm going to put it right here. So I'm going to separate the work space. So I'm going to continue over this side right here to find our total amount. So my total amount is going to be equal to, so that's going to be A is equal to, so 5,000 times the amount for 1.08 cube, that's going to be equal to 5,000. So that's going to be 6,298.56. So this right here is going to be my total amount. So A is going to be equal to that right here. And we know that everything that we have done so far right here, this formula, using this formula, is just to find the total amount. So that's A, total amount. Alright, so let's quickly finish it off. So after finding total amount, we're going to find our simple interest. So we know that A is the total amount, and our total amount is going to be this figure right here. So in order to find our compound interest now, so that's going to be CI. So CI stands for compound interest. That's going to be equal to the A, which is the total amount, minus P. So that's going to be the total amount minus principal. So that's going to be CI, compound interest, minus, so we're going to have the total amount, which is 6,298.56 minus the 5,000. So minus 5,000. And after subtracting, we will get our compound interest. So that CI now is going to be equal to, 1,298.56. So this right here, this figure right here, is going to be our compound interest after 3 years of gaining 8% per annum. So after finding the compound interest on 5,000 for 3 years at 8% per annum, right? So it's compounding annually. So this will be my compound interest. So let's move on. What if the interest is compounded more than once per year? So the formula that we have used before, this formula is if the interest is compounded yearly. That means year after year, interest is compounded. That means, compounding means that your money, keeps growing, or that's how we describe. But if your interest is being compounded yearly, then this is the formula that we'd use. So P bracket 1 plus R over 100, R raised to the T, right? So this formula right here is what we'll use if it's compounded yearly. But in a case where it is not compounded yearly, like for example, Mr. Brown invests $20,000 in a savings account that pays 6% interest per annum, compounded quarterly. How much money will he will be in the account after 2 years. Now, if you realize for this question right here, it says that within a year, it compounded quarterly. That means that it compounded what, 4 times per year. So how much money will be in the account after 2 years? So no longer, unlike the other questions before where compounded every year, it compounded 4 times within a year, right? So it's different. So whenever interest is compounded by a number of times within a year, this is the formula that we will use. Some persons would have already been exposed to this formula already, and that causes the confusion because they see multiple different formulas, but they don't know why we have different formulas for compound interest. So some person might see my formula at the start of the video and say, oh, this is easy compared to another video which showed this formula right here. But this is just the general formula for when you're finding compound interest, when the interest is being compounded for more times within a year. Alright, so A in this still stands for the total amount of interest. So the total amount, that's principal plus interest. P in this case right here stands for the original amount of money. So nothing changes. We still have our 1 being added to. So that's, we still have our 1 being added to. So we're looking at components of the formula that did not change. But if you look right here, we have R over N. So R over N, all raised to N again times T. So R raised to N times T. So N would be the new letter or the new variable in this formula that, is different. So what is N? So N is the number of times interest is compounded per year. So how many times interest is calculated and added to the principal each year. So that's the purpose of N in this formula right here. Is the amount of time per year that interest is being compounded, right? And R, we have R right here, and R over N. The R right here is just going to be the decimal rate. So if you realize when you put the R over 100, that result will be the R as a decimal. So this formula right here is used whenever we have the interest being compounded more than once per year. All right. So for persons who feel comfortable with the R over 100 because they don't want to, they got used to R over 100 now. Can we still have the R over 100 in this formula? Can we still have R over 100 in this formula so we don't make any mistakes? Yes, you can rewrite your formula where R is a fraction. That means the rate is a number over 100. We can still have that in this formula right here. And if we do that, the formula will look like this right here. So A is equal to P bracket. So that's going to be 1 plus R over 100 over N raised to N T. So R over 100 over N. That means that you have to find what is R over 100. So you, before you divide by N. And if you do that, if you find what is R over 100, you'll get your decimal just being R. So it will be, after finding the decimal, what is R over 100, you have a decimal R. So that decimal number representing R, you have that now over N. And that's the reason why we have our regular R over N, because the R right here is expressed as a decimal. So that's the reason why it's not, you don't have it over 100, because they simplified it where it's already expressed as a decimal. So we instead of having R over 100 over N, we just simplify R over 100 and we write that as a decimal number over N. So that's the reason why the formula before is there. Another way of writing it also, if you want to, you could have R over 100 times N, and you would have to divide what the rate is over 100 times N, not the decimal, but whatever the rate is over 100 times N. So if you are comfortable using any one of these formula as well, you can. So these three formulas right here being 1, 2, and 3, these three formulas, they are the same. They are not different formulas, they're the same, they're just represented differently. So you can choose which one you prefer based on how you prefer to work. So normally, because we have R over 100 for the first formula, if you want to have R over 100 over R, you can. Alright, so you can. So with that being said, we're gonna go and we're gonna utilize this formula right here if the interest is compounded by a number of times within a year. And we're gonna go back to our first example right here. So Mr. Brown invests $20,000 in a savings account that pays 6% interest per annum, which is compounded quarterly. So we write by substituting all our values that are known. So my P is gonna be 20,000, my R is gonna be 6%, my N is gonna be right here. Quarterly means 1/4, so 4 times. So that means 4 times. So 4 times. So it compounds 4 times. So that's my N. My time, so T is gonna be 2 years. Alright, so now that we have all three numbers, or all three variables, we're just gonna rewrite our formula now. So that's gonna be A is equal to, the total amount is equal to, our P is 20,000. Open bracket 1 plus R is gonna be 6%, and we know that's supposed to be written as a percentage, so that's gonna be 0.06 over the amount of times it, so that's N is gonna be the amount of times it compounded within a year, so that's gonna be 4 times, all raised to NT means that is raised to the product of these two numbers. So you have to multiply what N and T is, and when you finish, you raise that to that amount. All right. So that's gonna be N is 4, so 4 times. So 4 times T is 2. All right. So what we're gonna do, we're gonna first calculate the total amount in the bracket. So we're gonna first find the total amount in bracket, and then we're gonna find out what we're gonna raise it to after multiplying these two values right here. So you have to multiply before you get that number that you have to raise it to that power. Alright, so let's first work what is in bracket. So that's gonna be A is equal to 20,000 so that's 20,000, and we have 1 plus, so 1 plus so 0.6 divided by 4, that's going to be equal to, so 0.6 divided by 4 is going to be equal to 0.0, so that's going to be 0.015, and to find what we're going to raise that to, so 2 times 4, that's going to be 8, so we're going to raise this amount in bracket. When we find that amount, we're going to raise it to the power of 8. Because 4 times 2, N times T is, will result in 8 in this case right here. So let's quickly still find our final amount in bracket. So let's find our final amount in bracket before we raise it to the power of 8. So that's going to be A is equal to, and you know A means total amount, is equal to 20,000 times 1.015 raised to the power of 8. So all raised to the power of 8. So 1.05 raised to the power of 8. That means that you're going to multiply 1.05 15 by itself 8 times. Don't multiply it by 8. You're gonna multiply this figure by itself 8 times. So that's gonna be 1.015 raised to the power of 8. So that's gonna be equal to 6 decimal place around it too. If you wanted to multiply it by the full amount, that's fine. So equal to, so now we have A is equal to 20,000. So 20,000. So 20,000 times the alright, so this entire amount so that's 1.015 raised to the power of 8 will be equal to this right here below, and so that's figure right there. We just multiply it by each other. So multiply what is 1.0515 raised to the power of 8, multiply by 20,000, and you should get your final answer. We're gonna do it over that side right there to get our final answer. So I'm gonna be doing it right now. So I'm gonna first border with my highlighter and continue over the point. I'm gonna raise this to the second decimal place, so I'm gonna raise it just to 5. So I'm just gonna raise it to that. Other digits come afterwards, but I'm just gonna round it to the second decimal place. So this is gonna be my final answer right there. And please remember to add your $sign. So after 2 years, your money $20,000 will increase by $22,529.85 If you wanted to find your simple your compound interest, all you have to do is take away the $20,000 from the 22,590 and 29.85 to get your compound interest. So let's highlight this right here, and this is gonna be our total amount, because we know that A stands for total amount. So A stands for total amount. Yeah, so total amount. So that's the total amount after 2 years. Alright, so now that we have that out of the way, we're gonna look at this example right here, and we'll end the video with that example. Let's look at this one right here. So that's example. This is gonna be my second example because of the time. So a credit union offers 8% interest per year, so per annum, compounded monthly. So it compounded monthly. If Sarah deposits $15,000 for 3 years, calculate A, the amount in the account after 3 years, and also B, the compound interest earned. So first thing that we have to look at, looking at that question right there, we can see that that interest is compounded monthly. That's within a year. So that means that it compounded 12 times within a year. So let's write all our variables. So my compounded monthly right there, that's gonna be N, because that is telling me that it compounded 12 times monthly. So within a year it compounded 12 times. Remember, N stands for how many times it compounded within a year. So within a year it compounded 12 times. Alright, my rate right there is going to be equal to 8%. So that's gonna be my rate. The P, which stands for principal, the amount of money invested or borrowed, in this case right here, the initial money is $15,000. So that's gonna be my principal. 3 years, so 3 years right there. That's gonna be my time. Alright, so after we know all our variables, we're gonna first find A, and if asks us to find the amount in the account after 3 years. So that's the total amount. E stands for, so A is the total amount. So we're trying to find what A is. That's the amount in the account, total amount, gonna be equal to P is principal, 15,000, times 1 plus r, so that's gonna be times in bracket 1 plus r is gonna be 0.0. Remember, in this case right here, we're not gonna put it over 100, we're gonna use a decimal amount, so that's gonna be 0.08 all over. N means the number of times it compound within a year, so that's 12 times over the power of n again is 12, so we're gonna have 12 multiplied by t, which is time, and that is 3 years, so 3. Alright, that being said, we're gonna have our amount being, so a now is gonna be equal to 15,000 times 1 plus, so all of this is gonna be so 0.08, and the reason why I'm doing this right here, because I know what 0.08 over 12 is. That's gonna be a long decimal number. So what I am gonna do, so first thing first, I'm gonna find out what number I'm gonna raise all of that to. So I'm gonna raise it to. You have to multiply these two numbers together to know what to raise it to. So 12 times 3. So since we know what 12 times 3 is, we know that we're gonna raise it to the power of 36. Let's write that a little bit better. That's gonna be 1 plus 0.08 all over 12 raised to the power of 36. So in this example right here, I want to be as accurate as possible. So using my calculator, I'm gonna find out what all of this will be equal to, and then we're gonna multiply it by 36 because I want it to be as accurate as possible. But if you're not using your calculator, then you can do it like the example before, where you find what 0.08 over 12 is. You can perhaps round it to a number. I would suggest round it to a decimal place as close as possible to the exact number, but that number stretches infinitely. So you want to make it as accurate as possible. Then you add it to the 1 and you raise it by the 36 power, just like the example before. But in this case right here, I want it to be as accurate as possible, so I'm gonna use my calculator and I'm gonna find what 0.08 is all over 12. So 0.08 all over 12 is gonna be equal to 0.0666, stretches infinitely. I'm gonna so I'm gonna add 1 to that. So I'm gonna add 1 to it, or better yet, I could just write it down. So let's just continue. So I'm gonna continue because realistically, for those doing their exam, they would want to write down all the steps. So let's write down all the steps. So I'm gonna have a, so for those that's listening, what you could do, you could use your calculator and find all of this inside the bracket, then square it, and then multiply by 15 to make it as accurate as possible. But for the majority of students in their exams, we're writing step by step. I would suggest rounding it. So you're gonna have your 15,000 equal to 1 plus so that's gonna be 0.18 divided by 12. That's gonna be equal to 0.00666. 7 all raised to the power of 36. So I just made this as close as possible to the full extent. Alright, so 1 plus 0.006667, that's gonna be equal to A is equal to, that's gonna be 15 times 15,000 times that's gonna be 1 plus, so that's gonna be multiplied by, so it's in bracket I'm gonna have 1.0066667, and all of this in brackets is gonna be raised by the power of 36. And remember, it's raised by the power of 36 because 12 we have nt, so all of what is in bracket must be raised by, so it must be raised by the power of nt. So nt is gonna be 12, so 12 times that it is compounding within the year times t, which is the time, so 12 times 3 is equal to 36. So all of this must be raised by 36. So 1.00666667 raised to the power of 36. We're gonna multiply that by our 15,000, and we should get the total amount in the account for 3 years. So what I'm gonna do, I'm just gonna quickly separate my pages. My page or my board. I'm gonna quickly separate my board into 2 parts so I can continue working right here. So I'm gonna have A, so I'm gonna have A is equal to, A is equal to, so that's gonna be, so 1.006667 raised to the power of 36. It's gonna be equal to a number, and we just get a big number. We're just gonna multiply that number by the 15,000, and that should be equal to 19. We're gonna have 19,000 53, so 19,053.58 and 58 cents, and let's put the dollar sign right there. So $19,000 and $19,053.58, and this right here represents our total amount. So let's highlight that and represent it, and because that's gonna represent our total amount. That's gonna be our total amount. So that's gonna be the answer for A. That's the total amount in the account. Alright, and now that we know what the total amount is, we're gonna find our compound interest using the same formula, which is total amount minus, so total amount minus the principal. Alright, so let's continue it below right here. So we want to find what B is, so we already know what A is. So this right here, the total amount, this figure right here is the answer for A. So to find B now, we're gonna have to find the compound interest that is earned. So we're gonna find the compound interest. So out of the total amount, we're gonna find the compound interest. So compound interest, I said it before, it's gonna be equal to the total amount. So that's A minus P, which is the principal. So that's gonna be CI is equal to 19,000. So that's gonna be 19,053. So 19,053 and 58 cents minus the principal is right here, 15,000. So 15,000. Alright, and after subtracting, we'll have our simple interest to be equal to, so that's gonna be 19,000. So 19,053.58 and 58 cents subtracted by the 15,000, that's gonna be equal to 4,000. So remember to put the dollar sign now. So that's gonna be equal to 4,000 and $53, and we have 58 cents. 58 cents. Alright, so that's 58 cents. Alright, so that is gonna be your compound interest after 3 years. So please see the difference between the formulas. So if you look right here, or if you look at the two examples that I showed you, that we use this formula when we have the interest being compounded more than 1 times per year. But if it's not, and in most cases that or most questions that I see, I just see being compounded per year. So the first part of the video should cover what you mainly have to do in order to find compound interest, because for majority of the questions it compounds annually, so per year. So the first part would just cover that. Second part, this would be if it compounded more than 1 times within a year. And the good thing about it, this video kind of clarifies when you see different formulas, you don't get confused and say, okay, why do I see different formulas in different videos? You know why. So one is if it's compounded yearly, and the other is if it's compounded for more times within a year. All right.